This is Jyoshna from third year CSC A section in R. Shankara Institute of Technology. Today I am giving flat tech talk presentation. The topics of DFA and NFA and Mealy mission to Moore mission. What is DFA? DFA stands for Deterministic Finite Automata and NFA stands for Non-Deterministic Finite Automata. DFA cannot use empty string transition. NFA can use empty string transition. DFA is more difficult to construct. NFA is easier to construct. Time needed for executing an input string is less in DFA. Time needed for executing an input string is more in NFA. All DFAs are NFAs. Here, not all NFAs are DFAs. DFA requires more space compared to NFA requires less space than DFA. Dead state may be required here in DFA. Dead state is not required in NFA. Backtracking is allowed in DFA. Backtracking is not allowed in NFA. It is also not possible. DFA can be understood as one mission. NFA can be understood as multiple little missions computing at the same time. DFA rejects the string in case it terminates in a state that is different from accepting state. NFA rejects the string in the event of all branches dying or refusing the string. Next, what is Mealy and what is Moore missions? Mealy mission output. Here the output depends on present state as well as present input, and Moore mission is depends on output only upon the present state. Here if input changes, output also changes in Mealy mission. In Moore mission, if input changes, output does not changes. In Mealy mission, less number of states are required. In Moore mission, more number of states are required. The output is placed on transition in Mealy mission. The output is placed on state in Moore mission. In Mealy mission, it is very difficult to design. In Moore mission, it is easy to design. Here, the length of Moore mission is no longer than Mealy mission for given input in Mealy mission. Length of Mealy mission is 1 lesser than Moore mission for given input in Moore mission. In Mealy mission, the n+1 output symbols can be produced for n input symbols. In Moore mission, n output symbols are produced for n input symbols. Next, pumping lemma. The statement of pumping lemma is: pumping lemma is used to prove that language is not a regular. If alpha is a regular language, then alpha has pumping length p such that any string s where s mod s greater than or equal to p may be divided into 3 parts. S is equal to u, v, w such that the following conditions must be true. First conditions: u v power I w belongs to L such that I is equal to 0. Next, mod v is greater than 0. Third condition is mod uv is less than or equal to p. Let's see an example. Prove that L is equal to a power n, b power n such that n greater than or equal to 1 is not a regular language. Here a power n and b power n is same, so L is equal to maybe ab or 2a's 2b or 3a's 3b so on, or 4a's or 4b, etc. Here we take any one from above. We can take AAA, BBB. Then AA is U, A as V and triple B as W. From the above conditions, 1 to 3 conditions, The first condition is u v power I w belongs to L. We have to show that AA is u, a power I, that means v power I triple v. Here I is equal to 0. Then I power a is total got 0. It get eliminated from that. For that AABBB, here it is not belongs to the above language. Next second condition, mod v greater than 0. Here v is equal to only single a, it means 1. 1 is greater than 0, it's correct. Next third condition, mod uv less than or equal to p. uv is equal to triple as is equal to 3. Pumping lemma length, total length how much? 6. Therefore 3 less than or equal to 6. That condition is also true, but here the first condition is not true. It not belongs to that language, so it is not belongs to regular language. Hence we can prove that the given language is not regular language. DFA contains 5 tuples that are q, sigma, q naught, delta, f. Q is number of states or finite states. Sigma is inputs and q naught is initial state. F is a finite set of final states. Example B, B1, B2, so on. Next, delta is a transition function. Example, delta A, B gives rise to B. Here, sigma inputs that are, for example, inputs that are alphabets, finite set of symbols. String is a sequence of symbols over alphabets that is denoted with S. Example is sigma A, B is gives rise to S is equal to AB, BA, BB, etc. Next, language. Language is denoted with L. It is defined as set of all strings over the alphabets. L1 is equal to exactly of length. Next, finite automata. It contains 2 types, with output, without output. With output is a Mealy and Murray machines. Without output is a DFA and NFA. That's all. Thank you for giving this wonderful opportunity to me.